Okay. Hi. So in this class, we will talk about actually the tests related to indices and logarithms. In the previous 3 lessons, we talked about indices, and the second one, logarithms, and the applications of indices and logarithms. And today we are going to summarize all of this stuff and go and solve questions in this test. We have different questions from different parts of this, let's say, chapter. So we have around 8, 6, 14. We have around 18 questions. Okay. So let's start with this example. Arrange the following numbers. So again, we are just going to use, the basic simple properties of these indices to compare the powers of numbers, right? And usually we have 2 ways. Number 1, we need to bring them into the same basis, or we need to bring them into the same powers. If we bring them into the same basis, then we can just compare their powers, it means exponents, or if you bring them into the same powers, then just we need to compare their bases. So now here, as you see, the powers are, let's say, 700, 400, 300. And all of these numbers are divisible by 100. That means that the highest common factor of 700 and 400 and 300, that is 100. So x, I can just write it as 2 to the power of 7 to the power of 100, which is equal to 2 to the power of 7, that is 128 to the power of 100. And how about y? Y is equal to 7 to the power of 4 to the power of 100, which is equal to, what is 7 to the power of 4? Actually, 7 to the power of 4 is equal to 2,000, 2,401 to the power of 100. And z is equal to, we can write it as 11 to the power of 3 to the power of 100. And what is 11 cubed? 11 cubed is equal to 1331. That is 1331 to the power of 100. Now, all the powers are the same, right? So from here, which one is the smallest? It says ascending order from the smallest to the biggest. The smallest one is x. The second one, the second smallest is z, and the third smallest is y. Why? Because you see the basis, right? 128 is less than 1331. It is less than 2401. So dot, x is the smallest one, second smallest one is z, and the biggest of these numbers is y. Another example, arrange the following numbers in ascending order. Let me just use green. Solution. So what is the highest common factor of 108 and 90? It is 72, right? The highest common factor is, I think it's 18. Yes, it is 18. All numbers are divisible by 18. So now from here we can write x as 4 to the power of 18 times 6, right? So that is 6 and then to the power of 18. And what is 4 to the power of 6? 4 to the power of 6 is, that is 4,096. That's 4,096 to the power of 18. And how about y? Y is equal to 5 to the power of 18. Actually, first I need to write 5. Here we have 5. Here we have 5 to the power of 18. Right? So what is 5 to the power of 5? 5 to the power of 5 is equal to 3,125 to the power of 18. Okay. Hello, Dashel.
Hello, sir. Good afternoon. My laptop had problems with the audio, so I couldn't connect early. I'm sorry.
Okay, no problem. As you know, Dashel, today we are going to solve questions from the test. This is the last part of this series, let's say chapter, and I have just done only one example. Maybe later you can watch. Now I'm solving the second example. So we're going to solve mixed problems, okay, in this test. So here z is equal to, what is it, 6 to the power of 72. So we can write it as 6 to the power of 4 to the power of 18. So what is 6 to the power of 4? 6 to the power of 4 is 1296. That's 1296 to the power of 18. Now all the powers are the same, just we need to compare their bases. If you compare their bases, the smallest one is z, right? 1296 is less than 3125 is less than 4096. So it says ascending order from the smallest to the biggest. So z is the smallest, and the second smallest is y, and the biggest one is x. All right. Next question, evaluate this logarithm. So solution. So bases are the same and it is added, right? You're just going to use the property that if they have the bases and added, you can just write it, change this into multiplication. How? That is just logarithm. Here we have 13. Just now we need to multiply this 23 over 61 times 61 over 23, which is equal to 23 over 23 is 1. So it's just reciprocals of each other. So that's equal to log. Here we have 1 to the base 13. So 13 to the power of what number is 1 is just equal to 0. So this logarithm is equal to, is equal to 0. Another example solution. Logarithm of 14,641 and 13,331. Now from here 13,331, we know that it's divisible by 11, right? So even actually we know that it's just equal to 11 cubed. So how about 14,641? I don't know, but even if you don't know, you can just immediately divide this by 1331. We will see actually is it divisible or not. Actually, if you just divide this, you will see that this 14,641 is just equal to 11 to the power of 4, because 11 times 11 times 11 times 11 is equal to 14,641. Now I can just change the base of this logarithm, right? What is it? I can just change them because it is log 10, log 4. Anyway, first let me just write it as log here is 14,641. We can write it as 11 to the power of 4 over, here we have log, here we have 11 cube. And using the properties of logarithms, I can write it as 4 times log 11 over 3 times log 11. So these things are the same and they cancel out each other. So the answer is 4 over 3. And the challenge here is immediately you should find out the relationship between these numbers. These are just powers of 11. Anyway, next question. Given that 13 to the power of 200 is a 223 digit number, find the number of digits of 13 to the power of 22. So if you remember, actually, we know that if you just write 10 to the power of n, right? And this one is n plus 1 digit number, Since it says that 13 to the power of 200 is a 223 digit number, so that means that 10 to the power of 222 less than or equal to, here we have 13 to the power of 200, right? So because this one is the smallest 223 digit number. So it should be less than the smallest 224 digit number, right? That is 10 to the power of 2 to 3. This 10 to the power of 2 to 3 is a 224 digit number. So now if you just take the common logarithm of all sides, we know that the first part is equal to 2 to 2. That is less than or equal to, here we have log 13 to the power of 200, less than, here we have 2 to 3. Or actually this 200 comes to the front and then Even actually, I can just write it as 2 less than or equal to 200. And here we have no 200. And let me just write here log. Here we have 13 less than 223. So now if you just divide all sides by 200, divided by 200, divided by 200, 222 is divided by 200 is 111. That's equal to 1.11. Less than or equal to, here we have log 13. Less than 223 is divided by 200. It is 1.15, right? That's 1.115. Now, if you just multiply all sides by, we're going to multiply all sides by, what is it? The power of 23 is, 13 is 22. So we're going to multiply all sides by 22. So if you multiply 1.11 by 22, let's multiply this, that's equal to 24.42. Less than or equal to, here we have actually 22. Let me just write it as a power. Here we have 13 to the power of 22. Less than 22 times 1.115, that's equal to 24.53. It's just simple multiplication. That's why I'm just writing this directly. So this number, right, it is between 10 to the power of 24.42 and 10 to the power of 24.53, which means that actually, so that number is greater than, right, if I write here this one, I can write it as 10 to the power 24, right? So that's less than or equal to, what is it? Actually, this 24 means it is log 10 to the power of 24.42, right? So that means that this dot, 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 13 to the power of 22 must be, is, what is it? Is a 25-digit number. 5-digit number. Because the thing is that the power of 10, it is between 24.42 and 24.53. So which means that it is a 25-digit number. Next example. Given that log 2 is 0.301, log 3, that means common logarithm of 3, is equal to 0.477, find the number of digits of 18 to the power of 100. So that means how can I express this 18 in terms of log 2 and log 3, right? And I can just write here this log 18 that's equal to log, here we have 2 times 3 squared. Or that's equal to log 2 plus log 3 squared, that is 2 times log 3, right? So we know what is log 2, right? We know what is log 3 approximately. So after that, we need to find this. So to find this one, actually, since, all right, log 2, log 3, okay. 18, all right. So let's continue. Approximately, what is log 2? Log 2 is 0.301 plus 2 times, what is log 3? It is 0.477. So that's equal to 0.301 plus 2 times 0.477. That's equal to, what is it? 1 point, that's equal to 1.255. Okay. This is what is log 18 to the power 1. Now, if you just calculate this, what is it? Log 18 to the power of 100. So that's equal to 100 times log 18. That's equal to 100 times, what is log 18? That's equal to, let me just write it, times 1.255, which is equal to 125.5, right? So that's equal to this. So that means that actually I can just write it as, what is it? Log 10 to the power of 125, right? Less than or equal to log 10 to the power of, what is it? Actually, 125. Okay, 125.5. So that's equal to 125.5, and no, wait. Okay, this one is 125.5. So that is, we can write it as log 10 to the power of 125.5, right? Okay, so which means that then dot this 18 to the power of 100 is, what is it, 125 is one more than this, that it is 126 digits number. Why? Because this one is greater than 10 to the power of 125. It is less than 10 to the power of 126. That's this. Okay, part B, we have a few questions. It's about solving logarithmic equations. Okay, solve the equation for x. All right, solve the equation for x. So now first, let me just rewrite this in terms of the powers of x. The first one is, I can write it as, what is it, 2 to the power of 2x times 2 to the power of 2 times 2 is 4. What minus 65 times 2 to the power of x plus 4 is equal to 0. So now let me introduce new variable. Okay, suppose that w is equal to 2 to the power of x. So at the time, if you just write this everything in terms of w, 2 to the power of 4, that is 16, and 2 to the power of x to the power of 2, that is w squared, minus 65. So 65, 2 to the power of x, that's just w, plus 4 is equal to 0. So now it's just a quadratic equation. Can we solve this by factorization? I guess yes, it is 16w. Here we have w. This one is 1 and 4. Since it is minus, I should put here minus. If you cross multiply, 16 times negative 4 plus w times negative 1, that's equal to 65. So we can factorize it as 16w minus 1 times w minus 4 is equal to 0. Now from here, w is equal to 1 over 16, or w is equal to 4. What is w? W is 2 to the power of x. 2 to the power of x. What is 1 over 16? It is 2 to the power of negative 4. Or 2 to the power of x equals 2 squared. So from here, dot, x equals negative 4, or x equals 2. We have two possible solutions for this equation. All right, another example. All right, so in a similar way, okay, let me just introduce variables, and after that we'll just solve them, okay? So suppose that a is equal to 2 to the power of x, and b is equal to 3 to the power of y. So what is 2 to the power of x plus 2? We can write it as 2 to the power of 2 times 2 to the power of x. So which is, the first one is 4 times a plus b is equal to 577 over 9. Second one is 3 times a plus, And this 3 to the power of y plus 3, we can write it as 3 to the power of y times 3 cubed equals 3 cubed is 27 times 3 to the power of y. So that's equal to 27b. That's equal to 51. So it's just a system or simultaneous linear equations in two variables, right? So how can I solve this? Let me just do this by elimination method. I'm going to multiply the first equation by 27, okay? If you multiply the first equation by 27, 27 times 4, that is 108, 108 plus 27b. And 27 times 1 over 9, that is 3. So here we have 3 times 577. The second one, 3a plus 27b. That's equal to 51. Now, if you subtract the second equation from the first one, 108 minus 3, that is 105a. 27 minus 27, that's equal to 0. And how about 3 times 577? 3 times 577 minus 51, that's equal to 1680. Let's continue from here. From here, what is A? A is equals 1680 over 105, which is equal to, if you divide this, that's equal to 16. So what is A? A is equal to 2 to the power of x. That's 2 to the power of x. So immediately from here, we can find x. X is equal to 4. So now we got the value of x. Right. So now I can continue find B, right? Or another way is directly, we can just substitute into the first or second equation. We can find the value of y. Let me just substitute into the second equation. Since I know the value of x now, if you substitute into the second equation, we just write here this is the first step. Now here we have the second step. So that is 3 times 2 to the power of x, that is 44, plus 27 times 3 to the power of y. On the right hand side, we have 51. Now from here, what is it? 27 times 3 to the power of y is equal to 51 minus 2 to the power of 4, that is 16. 3 times 16 is 48, which is equal to 3. So 3 to the power of y is equal to 3 over 27. That's equal to 1 over 9. That's equal to 3 to the power of negative 2. Now from here, y is equal to negative 2. So dot, 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 x equals 4, y is equal to negative 2. That's the solution of this system. Dasha, is everything okay?
Yes, sir.
Very good. When does your school start, Dasha?
The start of September, sir.
September?
Yes, sir.
I see. Good. Okay. Another example, questions 3. Okay. So how are we going to solve this? Okay, I'm just going to use the similar methods. Okay. So suppose that here we have 2 to the power of x, let's say, is equal to a. And 3 to the power of, that's 3, here we have 5. 5 to the power of y, let's say it is b. Okay. So now, let me just rewrite the equation. After that, I will substitute. Let me just divide this into 2 because we're going to need more space. The first one is, I can write it as 2 times 2 to the power of x squared minus 15 times 5 to the power of y, which is equal to 1 to 5. The second one is, here we have 4 times 4 to the power of x, that is 2x squared, minus 4 to the power of x, that is also 2x squared, plus 5 to the power of y plus 1, we can write it as 5 times 5 to the power of y, that is 5 times b. And the minus, how about 5 to the power of y, that's just b. On the right hand side, we have 192.8. So now if I substitute those values into this equation, what do we have here? So here we have 2a squared minus 15b is equal to 125. How about the second one? Second one is 4a squared minus a squared plus 5b minus b, that's equal to 4b. That's equal to 192.8. But here for a squared minus a squared, we also just simplify this, write it as 3a squared. So that is 3a squared. Okay. So now let me just, solve this for a and b. First, how can we solve for b? The first equation, I should multiply both sides by the least common multiple of 15 and 4 is 60. So I should multiply the first one by 4, the second one by 15. Okay, so if you multiply the first equation both sides by 4, here we have 8a squared minus 60b. 4 times 125, that's equal to 500. The second one multiplied by 15, 15 times 3, that is 45a squared, plus 15 times 4, that is 60b, and 192.8 multiplied by 15, that is 2892. So now if you just add these two equations together, 8 plus 45, that is 53. So here we have 53a squared minus 60b plus 60b, that's equal to 0. And 500 plus 2892 is equal to 3, what is it? It's 3392. So what is a squared then? A squared is equal to 3392 is divided by 53, which is equal to, if you divide this, that's equal to 64. Okay, so we know that a is positive, right? 2 to the power of x is always positive, which means that here we have only one answer. A is equal to 8. What is a? 2 to the power of x. From here, x is equal to 3 because 2 cubed is equal to 3. Now we know the value of y. Again, I can just find b, substitute into the first equation, but instead, okay, I'm just going to substitute into the first equation. That's much faster. That gives me the solution much faster. So if you just substitute this result into the first equation, here we have 2 to the power of, let me just write it the second step. This one is the first step. 2 to the power of, what is 3? It is, x is 3. 2 times 3, it is 6. 6 plus 1, it is 7. So here we have 7 minus 15 times 5 to the power of y equals 125. Now from here, 15 times 5 to the power of y, 2 to the power of 7, 128, 128 minus 125, that's equal to 3. So from here, 5 to the power of y equals 3 over 15, that's equal to 1 over 5, or 5 to the power of negative 1. So from here, what is y? Y equals negative 1. So dot, x equals 3, and y is equal to negative 1. This is the solution of this system. All right, let's continue. Solve the equation. Also, last time we did similar one, right? I just start from here. This part, actually, this should be equal to this log. Here we have 3 in the base, and log, here we have x to the base of 2, that's equal to 4 to the power of 0, which is equal to 1. Now from here, logarithm of x to the base 2 equals, now here we have by definition 3 to the power of 4 to the power of 0, that is 1. So then what is x? X equals 2 cubed, that's equal to 8. So dot, the solution of this equation is, it is 8. Okay, so another logarithmic equation here. So here we have the base is 3. So 3. So that's a good thing. So now, of course, before we start, we have to make sure that this x plus 2 is greater than 0 and x plus 6 greater than 0. So that's greater than -6, greater than -2. So the domain is x must be greater than -2. So we are looking for the solution in this interval. So the first one, I can just write it as 3, right? So the left-hand side will be logarithm of, and the base here we have 3. It is minus, it will be divided. What is it? It is x plus 2 squared. First, I need to bring this inside, right? And here we have over x plus 6. On the right-hand side, we have log. In the base, we have 3. So here we have 4 to the power of 1 over 2. Because also this is in the front, but the coefficient will be the power of this 4. So bases are the same. So that's equivalent to this x squared plus 4x plus 4 over x plus 6. On the right-hand side, 4 to the power of 1 over 2, that's equal to 2. Or here we have x squared plus 4x plus 4 equals 2x plus 2 times 16, that's equal to 12. Okay. Now let's continue. So bring into the standard form of a quadratic equation. Let's write a bit nicely. So here we have x squared, 4x minus 2x, that is plus 2x, 4 minus 12 minus 8. That's equal to 0. And it's factorizable. We can solve this quadratic equation by factorization method. What is it? It is just 4 times -2, 4 plus -2. So that is x plus 4, x minus 2, that's equal to 0. So from here, dot, 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 x equals -4 or x equals 2. But actually, we are looking for the solution where x must be greater than -2, right? So it does not satisfy that condition. So this answer is rejected. The final answer is the solution of this quadratic logarithmic equation is it has only one solution, that is 2. Okay, let's continue question 6. We have how many questions? 6 and 7, 8. Okay. So now I think I need to speed up a little bit more, go a bit faster. Next question is, given that log 2 equals 0.301, log 3 equals 0.477, find the number of digits of 2 to 5 to the power of 100. So it says it is 2 to 5, right? 2 to 5 is 15 squared. So let me just write log 2 to 5 is 15 squared, or I can just write it as 2 times log, it is 3 times 5, or that's equal to 2 times log 3 plus log 5, which is approximately equal to 2 times, what is log 3? Log 3 is, okay, log 3, no log 3, but how about log 5? I need to do something else with log 5. Anyway, so let me just stop here. How about log 5? How can I express this log 5 in terms of 3 or 2, right? So again, log 5, I can just write it as, what is it? Okay, chain to the base of 5. All right, so you can just write it as logarithm of 5 to the base of 5 over logarithm of 5 to the base of this 10, right? So it is, I'm changing to the base of 5. It is 10. So this one is 10, and here we have 5. It's simple, actually, we know the rule. I can just change this into this form, right? Because we just write the logarithm of a to the base b is equal to 1 over logarithm of b to the base of a. So now from here, I can just write it as, what is log 10? 10 is 2 times 5. So we can write it as log 2 to the base of 5 plus 1. Hmm. 5, 10. No. 2 to 5, 15 squared. 3 times 5. 6, 5. I think I made something wrong here. Okay. Okay, that's the first step. Let me just do step by step. Log 3, we know what is that, but log 5. How can I express log 5 in terms of, what is it? 2, right? So this log 5, I can just write it as log, it is 10 over 2. That's equal to log 10 minus log 2. And what is log 10? That's equal to 1. And log 2 is, what is it? 0 0.301, which is equal to approximately, of course, that's equal to 0 0.699. Right? Okay. Let's count it. That's it. That's what I need actually. So log 5 is equal to this. So now if I just come back to the first one, so now from here, log 15 squared is equal to 2 times log 3 plus log 5. That's equal to 2 times, what is log 3? Log 3 is 0 0.477. I can just write here, it is approximately equal to 2 times plus, what is log 5? That is 0 0.699, which is again equal to 2 times, that is 2 times 0 0.477 plus 0 0.699. That's equal to 2.352. Okay. Anyway, so that's it. So this log 15 squared, like 205, that's equal to this. Okay. So now the third step, let me just change the color here also. So 225 to the power of 100, right? We can just write it as log 10 to the power of all right, log 225 to the power of 100. We can write it as 100 times log 225. So that's equal to 100 times, what is log 225? We have just found here, that's equal to 2.352, which is equal to multiplied by 2,235.2, right? So that means that that thing is greater than, what is it, 10 to the power of 235, right? Because that one is, it is 10, 2 to the power of 100, right? I can just write it as, this one is greater than 10 to the power of 235, which means that from here then, this 225 to the power of 100 is at 236 digits number. Let's continue. Another question, question 7. Solve if 11 to the power of a equals 13 to the power of b equals 143. Evaluate 1 over a plus 1 over b. Right. Now from here, if you just take logarithm of both sides of these two numbers with respect to 11 or to the base 11, so here we have a by definition, right, that's equal to log. Here we have 143 to the base of 11. And how about b? That is log 143 to the base 13. Now from here, what is 1 over a plus 1 over b? That's equal to, again, just change using this rule. I'm just going to use this one logarithm of a to the base of b equals 1 over logarithm of b to the base a. So that's equal to 1 over, right? Actually, I can just write 1 over a, but immediately I can just write it as log. Here we have 11, 143 plus log 13, 143, which is equal to log in the base we have 143, 11 times 13, that's equal to 143, which is equal to 1. So the value of this thing, it should be equal to 1. Question 18, similar question. Again, we just want to take, what is it? Again, first b minus a over ab. I can write it as b over ab minus a over ab. That's equal to 1 over a minus 1 over b. Okay, so now again, using the previous method, now what is a? A is equal to log, here we have 39 to the base 351. The second one is, what is b? Here we have log 39 to the base 3 over 30. Now, how about 1 over a minus 1 over b? 1 over a minus 1 over b is equal to 1 over a is, here we have log, also we should just change upside down, 351 to the base 39 minus log, the second one is 3 over 13 to the base 39. Now bases are the same, so we can just write it with a single logarithm to the base of 39. Since it is division, so here we have 351 divided by 3 over 13. So which is equal to log, in the base we have 39. What is 351 and times, right, it is 13, and divided by 3, that's equal to 1521. And what is 1521? 39 squared actually is equal to 1521. So we can just write it as log, here we have 39 squared, which is equal to 2. So the answer is, what is it? It is 2, dot, dot, dot. The answer is 2. Okay, that is part B. Now we have 6 questions in part C. Let's see how much we can do. We are running out of time anyway. Part C. Given that a minus 1 over a is equal to 2, evaluate this. And usually, how can we do this? Since here we have a minus 1 over 2, right? And if you just square both sides, I have a minus 1 over a squared is equal to 2 squared. On the right-hand side, we have a squared minus 2 times a times 1 over a is just equal to 1, and plus 1 over a squared, that's equal to 4. Now from here, what is a squared plus 1 over a squared is equal to 4. Take negative 2 to the right-hand side is equal to 6. The first step. The second step, now let me just square both sides one more time. So here we have a squared plus 1 over a squared and squared. On the right-hand side, we have 6 squared. Again, if you just expand the left-hand side, here we have a squared plus 2 times a squared times 1 over a squared, that's equal to just 2. And here we have 1 over a to the power of 4. That is 36. So from here, it should be 4 here. Dot, 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 a to the power of 4 plus 1 over a to the power of 4 is just a to the power of negative 4. That's equal to 36 minus 2. That's equal to 34. Okay. Find the maximum value of the thing. We have done this before. As see here, since we are given that 0 is less than or equal to x is less than or equal to 1. First, let me just multiply all sides by 7 to 8. So here we have 0 less than or equal to 7 to 8, x less than or equal to 7 to 8. So now I'm going to add 1 to all sides and divide by 81. So here we have add 1, that is 1, divide by 81, less than or equal to 7 to 8x plus 1 over 81. Less than or equal to 7 to 8 plus 1 over 81. Okay. So that's it. So now if you just take logarithm of all sides with respect to 3, what we have here? This 1 over 81, it is 3 to the power of -4. So here we have log the base 3, 3 to the power of -4. Less than or equal to, here we have log 7 to 8x plus 1 over, here we have 81 to the base 3. Less than or equal to, about 7 to 8 plus 1, it is 7 to 9, right? If we divide it by 81, that's equal to 9. So here we have log, here we have 9 is 3 squared to the base of 3. So here we have -4, right? That means that this one is, that's just equal to -4. And this part is equal to, what is it? It is just 2. And since we need to find the maximum value of this one, let's say the whole thing is equal to this. Then here we have a maximum, it is squared, so it is -4 squared is equal to 16. Question 3, given that logarithm of 2x plus y minus 2 to the base of 5 is equal to 1, and logarithm of x minus 2 to the base 5 equals 1 plus 2 times logarithm of y to the base of 5, find the value of x and y. It's a kind of, solving system of logarithmic equations. So the first one immediately, let me just write it as 2x plus y minus 2, by definition, that's equal to 5 to the power of 1. It's just equal to 5. Over the second equation, first let me just rewrite this, that is log, here we have x minus 2 to the base of 5 is equal to, and this one is 1, I can just write it as log 5 to the base of 5 plus logarithm of, in the base 5, here we have y squared. So we are talking about the system. So the first part, let me just simplify again, 2x plus y. Take -2 to the right-hand side, that is 7. And how about the second one? If you simplify this, x minus 2 should be equal to 5. And plus means multiplied. Here we have y squared. Okay, so we have to solve this system. How do you do that again? If you just multiply the second equation by 2, we can eliminate x. And after the solve for y, and after that, we can get the value of x. So let's continue here. Let me just rewrite here. 2x plus y is equal to 7. Multiply the second equation by 2. 2x minus 4 is equal to 10y squared. So if you subtract the first equation from the second one, 10y squared minus 7 is equal to -4 minus y. Right? I just subtracted the first equation from the second equation. So if you take everything to the right-hand side, then here we have 10y squared plus y, -7 plus 4, it is -3. That's equal to 0. Okay. So now let's try to solve this by factorization. 3, 10 doesn't work. How about 2y and 5y? And here we have 1 and 3. It is plus, so I should put minus here. If you cross multiply, 6 times 2y, 6y, it is -5, the sum is this. Okay, it works, so I can factorize as 2y minus 1 and 5y plus 3. That's equal to 0. From here, y equals 1 over 2 or y equals -3/5. Now, of course, here in the logarithm, right, from here, y must be positive. And that's why this answer is, what is it? Rejected. So y is equal to only 1/2. So since y is equal to 1/2, I can just substitute into the first equation to get the value of y. So 2 times x plus, what is y? 1/2, that's equal to 7. So what is x then? It is 6.5, that's 13/2. That's equal to 13/4, which is equal to 3.25. Okay, so dot, x equals 13/4, and y is equal to 1/2. These are the solutions of these equations. Okay. Next question. We have 4, 5, 6, 1, 2. Okay. Let's try to finish everything. Solve the equation for x. 2 times log x plus 2 times log 10 to the base of x minus 5 equals 0. So simply here, suppose that logarithm of x to the base 10, actually we don't have to write 10, it's just log x. Suppose it's equal to t. So at the time, this log 10 to the base of x will be equal to 1/t. Of course, here x is greater than 0 is not equal to 1 because it's also in the base. So now if you substitute here we have 2 times t plus 2/t minus 5 is equal to 0. Okay. So if you multiply both sides by t, because t is not equal to 0, here we have 2t squared minus 5t plus 2 is equal to 0. So, and again, we got quadratic equation here, 2t, 1, 1, 2, right? It's minus. If you cross multiply, this one is t. So if you cross multiply, -4t, -1t, the sum is -5t. So we can factorize it as 2t minus 1, and t minus 2 is equal to 0. So from here, t is equal to 1/2, or t is equal to 2. Let's just write it here. The answer will be, what is t? It is 10 to the logarithm of x to the base. So logarithm of x to the base, actually just 10, that's equal to 1/2, right? From here, what is x? X equals 10 to the power of 1/2, that is square root of 10, right? That's the first one. And the second one is logarithm of x to the base 10, that's equal to 2. From here, what is x? 10 squared, that's equal to 100. So dot, the solutions of this equation is square root of 10, or x equals 100. Question 5. Solution. (27 to the power of something, 3 to the power of x, right? So again, let me just simplify this. W is equal to 3 to the power of x. So what is 27 to the power of x plus 1? We can write it as 27 times 27 is 3 cubed, right? So that will be w cubed. Plus, here we have 18. This 3 to the power of 2x, that is 3 to the power of x squared, so that is w squared. Minus, here we have 3w minus 2, that's equal to 0. Now we have cubic equation, right? So from here, as you see, let me just group and try to factorize this. Here, the common factor is 9w squared, and here common factor is -1. So here we have 9w squared. What is that here? Here we have 3w plus 2, right? Minus, here we have 3w plus 2, that's equal to 0. So 3w plus 2 times 9w squared minus 1 is equal to 0. Or if I just factorize this completely, we have 3w plus 2. So this one is 3w squared. So it's 3w plus 1 and 3w minus 1 is equal to 0. So from here, what are the solutions of this equation? W equals minus 2 over 3, or W equals minus 1 over 3, or W is equal to 1 over 3. So I can just write here, that means that 3 to the power of x equals minus 2 over 3. So that means that here, okay, 3 to the power of x equals minus 2 over 3, or 3 to the power of x equals minus 1 over 3, or 3 to the power of x equals 1 over 3. So powers of 10 is never negative, so this answer is rejected. And also 3 to the power of x, also it is negative, also this answer is rejected. So now from here, then what is x? X equals negative 1. So it has only one solution here, dot, dot, dot. X equals negative 1. It has only one solution. Okay. Another question. Solution. So logarithm of x over 12 to the base 2 is between this. So that means that minus 32 less than or equal to logarithm of x over 12 to the base 2 power 5, right? Less than or equal to 243. 243. So what is 32? Actually, I can just write 32 as 2 to the power of 5. And how about 43? It is 3 to the power of 5, right? So now, since the powers are odd, right, we can just draw the powers. So that is equivalent to this inequality, minus 2 less than or equal to logarithm of x over 12 to the base 2 less than or equal to 3. So which means that by the definition then, that is 2 to the power of negative 2 less than or equal to x over 12 less than or equal to, what is it, 2 cubed, right? Or if you just multiply all sides by 12, what is 12 times, if we have 12 over 2 squared, that is 4, less than or equal to x, less than or equal to 12 times 2 cubed is 8. So the domain of x, right, the domain of x will be, the domain will be 12 over 4. It is 3, 12 times 8, that is 96. Okay, here we have 2 additional problems, okay, and after that I will finish the class. Okay, so solution, we use green. So a plus a to the power of negative 1, that means that is a plus 1 over a equals 3. So we need to find a to the power of 5 plus a to the power of negative 5. First, if I just square, the first step is, let me just square both sides. So here we have a plus 1 over a, here we have squared, equals 3 squared. So the left-hand side, we have a squared and plus 1 over a squared. On the right-hand side, we have 9. In the middle here, we have 2 times a times 1 over a, which is equal to 2, right? Constant number. Take to the right-hand side. Here we have minus 2. So that's equal to 7. Okay. So now, let me just square one more time. If you square one more time, a squared plus 1 over a squared squared is equal to 7 squared. So here again, we have a to the power of 4 plus 1 over a to the power of 4. Here we have 49, right? In the middle, we have middle term is 2. 2 times a squared plus 1 over a squared. That is 2. Take to the right-hand side, that's minus 2, which is equal to 47. But here we need to find a to the power of 5 plus a to the power of minus 5. So what am I going to do here is, okay, if I just multiply this by a, I will have a cubed. So I need one more thing, okay? What happens if I just multiply this a plus 1 over a by a squared plus 1 over a squared? What is a plus 1 over a? It's given, that's equal to 3. And how about a squared plus 1 over a squared? We have just calculated here, that's equal to 7. Now, if you expand the left-hand side, a times a squared, that is a cubed. 1 over a times 1 over a squared, that is 1 over a cubed. 1 over a times 1 over a squared, that's just actually 1 over a times a squared, that is a. A times 1 over a squared, that is 1 over a. That's equal to 21. So from here, I'm just trying to find the value of this. So here, a cubed plus 1 over a cubed, that's equal to 21 minus a plus 1 over a is 3. That's equal to 18. All right. So now, to get the solution for this question, let me multiply this. A plus 1 over a times a to the power of 4 plus 1 over a to the power of 4. What is a plus 1 over a? That's equal to 3. And a to the power of 4 plus 1 over a to the power of 4 is 47. So here we have 47. So which is equal to 120, 21, right? That's equal to 141. So if you expand the left-hand side, a times a to the power of 4, that is a to the power of 5. 1 over a times 1 over a to the power of 4, that is 1 over a to the power of 5. A times, actually 1 over a times a to the power of 4, that is a cubed. 1 over a times 1 over a to the power of 4, that is 1 over a cubed. That's equal to 141. Now, if I just keep this part on the left-hand side, so we got here a to the power of 5 plus 1 over a to the power of 5 will be equal to 141. What is a cubed plus 1 over a cubed? That's equal to 18 minus 18. That's equal to 123. So this answer is dot, dot, dot. That's equal to 1, 2, 3. That is the answer. That's how we do this. Actually, the challenging part is to be able to see this part, how we obtain this a to the power of 5 plus 1 over a to the power of 5. Okay, the last question. Let me use clean here, solution. In this question, it says that x to the power of logarithm of x to the power to the base of 11 equals 121x. So if x is less than 1, find the value of x. So let me just take the logarithm of both sides with respect to the base of 11. So at that time I have here log, here we have x to the base of 11, the power of this one log, here we have x 11. On the right hand side, we have log 1 to 1 x to the base 11. So that's just the power of x, right? It comes to the front. So here we have log x to the base of 11 times log x to the base of 11. But on the right hand side, I can just write it as log 1 to 1 to the base x plus log x to the base 11. Okay. So this is 11. So now from here, suppose that actually that thing, okay, that's equal to t. So here on the left-hand side, we have t squared. Take to the left-hand side minus t, and logarithm of 121 to the base 11, that's equal to 2, because 11 squared is equal to 121. That's equal to 0. So now from here, if you factorize this, t minus 2, t plus 1 is equal to 0. So from here, t is equal to 2, or t equals -1. What is t? T is logarithm of x to the base 11, that's equal to 2, or logarithm of x to the base 11, that's equal to -1. From here, x equals 11 squared, that's equal to 1 to 1, or x equals 11 to the power of -1, that's equal to 1 over 11. But in the question, it says that x is less than 1, right? Is it less than 1? Let's check. Uh, so logarithm of x, x11, okay. 121, that's equal to 2. Okay, plus x 2 minus the plus 1. Okay, 2 minus 1, 11 squared. Okay. So I think, I don't know, maybe the question is wrong, or if x is less than 1, we don't have any negative answer here. Because whatever it is on the left-hand side, we have positive. Anyway, if x is greater than 1, we have one answer. If x is less than 1, then here we have no solution. Because if x is less than 1, I just check the paper again. Again, it should be less than 1. If it is so, we have no answer here. Ashel, thank you very much for your time to join the class, okay? And I wish you good luck. Maybe one day we will see you, we will meet you again here, okay? Have a good day. I'm finishing the class. Bye-bye.
Thank you, sir, and goodbye. Have a good day too.
You too, thank you.